What we're here to discuss today is machine learning and artificial intelligence. For me, they are one and the same, not because they're one and the same, because people confuse between them, so I treat them the same. And we're going to see what role it plays within the communication space, especially real-time communications. I am Tzachi Levent-Levy, and with me is Chad Hart. I operate Blog Geek Me, a blog that talks around WebRTC, machine learning, and communication as a whole. I'm a consultant and the co-founder and CEO of TestRTC. Chad?
And so I said I'm Chad Hart. A lot like Sai, I'm also an independent analyst and consultant, focusing on WebRTC and AI and RTC. And I run a couple blogs. One is a blog for WebRTC developers over at WebRTC Hacks. And I also started a new one on the artificial intelligence and real-time communications topic, and that's at cogit.ai.
Okay. So, as I said, any questions, use the chat or use the Q&A. And here's what we're going to do today. Okay, there will be short introductions, why we're here, what we've done, and then we'll start looking at why now. Why are we talking about machine learning in communications at this point in time? Some of the alternatives that we have out there when we want to build something using AI for communications. We'll see some real-world examples, and then we have a bonus for you.
So before we start, just sort of background on how we got into this topic. We were really curious, what the state of the art was in terms of, artificial intelligence and machine learning amongst the real-time communications community. And we really want to see what were the major use cases out there. And specifically, we're both very product-oriented. We were very curious to see exactly how is machine learning and some of these artificial intelligence technologies, how are they being built into real-time communications products, right? And what are some of the major selection criteria that vendors and implementers should consider as they pick those options, those alternatives, or those solutions? So to answer a lot of these questions, well, we decided to get together and collaborate on a market research report. And we ended up actually talking, covering more than 120 different companies. We had in-depth interviews with more than 40 different vendors, technology vendors who are actually with deployments and customers and doing this in the real world. And to supplement that, we also ran a web survey where we actually had 105 respondents. And in addition, Sai and I often go to events. We have particular interest in a lot of the AI events and other communications industry events that had some kind of AI or machine learning focus or topic areas.
So why now? There are several reasons why we're talking about this at this point in time. And first and foremost, there is Moore's law. It's the excuse for everything that is done these days or in the last 20 or 30 years. We know that there is an exponential increase in the compute and storage power that we have. What was available 10 or 20 years ago, what wasn't available 10 or 20 years ago, or only thought of as something that is really, really expensive, is now in our pockets. These are things that we can use today. This huge availability of compute and storage came to something that was starting to be called big data, sometime like 10, 15 years ago, where the notion of big data is rather simple. It means we're going to collect first everything that we can, and then we're going to ask questions later. Okay, so whatever it's out there that we have, we store. If it's clicks or interactions or voice calls or video sessions, everything, we go and store it in a big pile of data, and then we maybe or maybe not do something with it. And then the question becomes, what questions should I be asking? Whereas before that, we started by what things we want to solve, what is our question, and then we started designing and collecting the data that we needed for that specific need. Okay? Because storage became so cheap in a way, it was easier to first collect and then decide what to do with it. Now, the second thing is, or the second trend is the cloud. Before cloud computing, what we had is islands of islands of communications, of islands of applications. If I were a vendor building an application for an enterprise, the end result was me installing that application within that enterprise with its own single database, and the customer that used it in a silo, in an island. Different customer installed that same software yet again with his own database. Now today we've moved toward the cloud where there is a multi-tenancy kind of a concept, which means that there is a single app, usually with a single database, and all of the different customers coming from different enterprises sit on top of the same app using the same large database. And now the application vendor has all of these data available for him to look at. Okay? Before that, he had no data. He just went and installed it within an enterprise, and then the enterprise had the database but didn't know what to do with that data. Now the data belongs to someone that knows what his customers are doing and can decide to do something based on a lot of data across multiple customers. Now, the next thing that happened, or something that happened in parallel, is we started finding out or remembering the fact that there's something called deep learning and neural networks. These algorithms allow a machine to learn complex models on its own. Okay? So instead of me deciding to do linear regression or things like that, I would give the data to the machine, tell it to learn a very specific thing that I wanted, and the machine would deduce what happens. Now, the end result is such that we can't really know how it got to the insights that it got to, but it is based on the data that it has seen in the past. Now, these new ways of learning allowed us to do things that we couldn't do before, like more accurate computer vision and speech analytics. Last but not least, cloud APIs. We have the large cloud vendor providers, Amazon, Azure, Google, and IBM, and they are offering today machine learning APIs for everyone in the cloud. So instead of going and searching for the algorithms and how to use them and how to scale them and how to collect the data for them, and sometimes even how to bring and create models to use for inference, you get that out of the box from these vendors. Okay, which made it very easy for companies to use. It democratized machine learning in a way.
So after reviewing and looking at the applications and use cases, we ended up dividing our findings broadly into the four main groups, and I'll walk through them individually. So the first and by far the most common was speech analytics. And there's really a broad range of use cases here, from providing transcription on conference calls to providing real-time agent coaching based on what customers say in the call center. Another big area is voice bots, right? And this includes smart speakers like Amazon's Echo and Google's Home, but also AI assistants like Siri or even like Bixby, right? Building a voice bot is complex. You need to consider transcription of the speech, running natural language understanding on that to try to interpret what was said, right? And then you also need to generate speech back and deal with customer activity in real time, right? And there's really a broad interest and growing use of these voice bots, not only for in the home, right? But the idea is that to use these actually on calls and to help facilitate calls. And we really see almost every telephony device maker interested in adding voice, some kind of voice user interface to their products. And this is a really natural fit because users are already speaking to these devices already. So it's a natural progression to speak to them to help to set up a call, for example. The third major category we looked at is computer vision. And this domain already had a lot of usage in consumer applications, and really just starting to find some business use cases. There are examples of some applications are counting people, identifying faces, using gestures for controls, and even augmented reality. And the last area is kind of a more of a general area, but what we call, real-time communication optimization. There are a lot of opportunities to use machine learning to improve underlying VoIP technology and really make the improve communication efficiencies at the human level. And one example that we had at our AI and RTC event with Cranky Geek, RingCentral showed how they used machine learning to help normalize some of their voice quality scores amongst different systems to give a consistent response to help them with debugging diagnosis. In implementing AI and RTC, we found there was three major paths, right? And Sai touched on some of these already. One, big cloud vendors. Two, there's a large number of startups and specialty vendors out there. And three, there's a growing open source community. Right, within the big cloud vendors, there is a lot of aggressive competition that's been going on for years. And you'll see all the high-level checkboxes are covered. But as you dive into the individual APIs and capabilities, there are, in a lot of cases, some pretty significant differences between the products as the vendors try to differentiate amongst each other. As an example, if we take, say, text to speech, pretty much all the vendors have some basic capability. There's a technology called speech synthesis markup language that allows you to actually change the tone and pacing and prosody of the output speech, so it sounds a little bit different, so you can customize it. But that's nowhere near as good as actually having a variety of different voices to choose from in the first place, right? So we see vendors expanding the number of voices they have available, expanding into the different types of languages that they support as well. And then, to keep things moving, right, Google with their DeepMind AI lab, came out with a much more human-like voices, that falls under their WaveNet capabilities, right? But say even if that you want something that's more customized, more personalized, you might, vendors like Microsoft with Azure have a customized speech engine where you can actually train and develop your own voice and make it even more unique, right? So we see a lot of back and forth and very rapid evolution here amongst the cloud vendors. There's also a large number of specialist vendors, and in this case, I'm showing just a subset of some of the speech analytics vendors out there. They all do basic speech to text in most cases, or have those capabilities, but we do see them starting to evolve into various different specializations. There's a bunch of vendors out there that are just, say, looking at how do we improve sales interactions, right? How can we help coach a salesperson to say the right thing and follow the optimal script. There are other vendors who look to augment and facilitate online meetings and conference calls, right? There are other vendors who specialize not specifically just in text or not in providing a text transcription, but providing paralinguistic analysis, right? Looking beyond the words and what's spoken and try to interpret tone and sentiment just based on the actual speech waveform instead of looking at the text, right? And that's very valuable. Certainly, if you think of something like sarcasm, you could say the same thing in two very different tones, and it means something very different. And there continues to be, in addition to a lot of the traditional call center speech analytics vendors, there's a large number of smaller specialists that focus on one area or one capability, or can help a call center do some sort of customization if they need to. And that continues to be a very active area. In addition, the landscape here is also changing, right? So in this case, I crossed out TalkIQ. That was an example of a company that actually was acquired by Dialpad. Dialpad, now that capability is only available via Dialpad's, unified communication as a service offering. We expect to see a lot more of that. In fact, there's really no major call center vendor out there that doesn't have some sort of speech analytics capability built into it already. And a lot of that came from past acquisitions, or at least were jump-started by past acquisitions. As this technology matures, particularly for like meetings use cases and more general unified communications, we completely expect to see the same thing happen. And many of these vendors get sucked in to other organizations. One of the other things that's really driving AI in general and helping AI in real-time communications in particular is the large number of open source resources that are out there. There's a large number of frameworks you can work from. By far, our survey results found that TensorFlow is by far the most popular. But even beyond that, there's a large number of other frameworks that are supported by major vendors like Facebook or Apache, right? There's a number of different speech analytics, voice bot, and computer vision platforms. So it's actually easier than ever if you want to go with the commercial approach, right? And that's there, but there actually is very good support in a lot of cases for some of these open source projects too, with growing communities. And as I just want to highlight one example. So in one case here, Mozilla has a project called Deep Speech, where they're providing a speech-to-text service, right? And Mozilla wants to do this because they see it's important to say build in this capability. They might want to have that as part of their browser. To complement this, though, you need more than just having algorithms, right? To do the analysis, you actually need to have a lot of data. And to complement this project, they had a sister project called Common Voice, where actually users can go to the website and speak a few phrases, right? And these phrases help to train the algorithm and improve this. And this is all done on an open source basis. So anyone can go and actually use, get access and reuse that data. So this is pretty exciting. It helps to really just expand the community and different applications and use cases, and just prove that you're not always dependent on the big vendors, who are certainly many years ahead in all these areas, but you're not necessarily just dependent on them to have good technology support here.
Chad, have you contributed your voice to science?
I have several times. I just say that it's not just other vendors. Even Google has some open source projects like this, and others too. So it's not just Mozilla.
Yes, I think theirs is very polished. It's very easy to use as a user and play with it, and you spend 5, 10, 20 minutes just diving into that thing and just talking or doing the tagging of others who spoke. So it's really interesting.
Yeah, I definitely encourage everyone here to just search for Common Voice and go in and check it out and see. It just takes a couple minutes. I also want to point out too is that in addition, to open source vendors, I mean, that there's also these hardware kits. The hardware kits themselves are, the software is basically open source, but you need to have specific hardware. In this case, I'm showing a kit from Google, their AIY Vision Kit. And their intent here is to make it easy to get started with computer vision. They have embedded Intel chip, but there's also kits like this that are available from Amazon. AWS has one called Deep Lens. Intel has some of their own kits, NVIDIA and others, right? So there's a lot of these kits out there. So if you're building, say, a in-room conferencing system, right, and you want to add computer vision to it and have that be on device, that there's a lot of options out there that are relatively easy to get started with for evaluation. And a lot of this stuff, even the hardware itself and the hardware specs themselves are open source, right? So they make it easy to get started. In this case, a lot of the software is based on TensorFlow. Google is interested in supporting that, but the specs and the hardware and all comes from Intel. It's all sort of things that if you're a manufacturer, you can go and build yourself. But this allows for very rapid prototyping. Sorry,
Okay.
I'll hand it back to you to walk through
Yes.
some examples.
Yeah, so we've seen a lot of these vendors, what they do, how they help us, where we came from. Let's look a bit of it on a few real life examples of companies that use today machine learning for communication purposes. And I start with something that was just announced last week, I think, called Google Calljoy. Calljoy is a service for the SMB where you get a number from Google, and then you can just announce that number, and people will dial that number instead of your direct number. That number will do three things. First of all, it will block spam. Second thing, it will deal with call deflection. So a lot of these calls, instead of directing them to a human, will be directed to a URL, for example, to an ordering system. And then the third thing it does, it just records and transcribes all the calls. And then it shows insights and BI emails, business intelligence emails with dashboards from that. So what do we have here? The first part of blocking spam, I have no clue how Google does that, probably by using machine learning across all of the Android devices that have out there and the calls in these devices. The second thing of call deflection works in that way. First of all, someone dials in, he calls, he's told that this call is going to be recorded for whatever crappy reasons. And then he's going to be asked, do you want to complete your order? If yes, we'll send you a URL. If that happens, the user will get a URL by SMS. If he clicks that URL, he is out of Calljoy now, and he uses a different type of a system that got integrated with Calljoy, where he can continue his order or whatever it is he wanted to do. Okay. Now, in order to do that first interaction, there is a voice bot. But the voice bot doesn't do a lot. It's not as if it goes and understands different types of intents that users have. It deals only with one question, and that question is, do you want me to send you a link? Yes or no? Okay, and then the answer can be yes, yep, sure, let's do that, whatever. Okay, it will go, understand this answer, this response, and decide if he's going to direct the call towards a human within the business, or will it just send an SMS and close the call and disconnect the call? Okay, so that's machine learning in the domain of voice bots. Next, what it does, the call happens, the human answers, takes the call, understands what's happening, deals with that. That call gets recorded and transcribed. So now we have that information available. Users can later go, okay, and tag calls with different indications or decide the word order or transaction is very important to me. And then you can go and search for all calls yesterday that had order inside them. So all the orders, okay? And that's based on speech analytics. And today what's happening in a lot of areas, the ability to transcribe a call becomes table stakes. It is understood that this is something that needs to happen. I guess that 2 or 3 years down the road, this will be something that is obvious and almost mandatory in any service out there. The other thing that we have is image manipulation. And with image manipulation, there are different types of doing that. Let's go from left to right. The left side, hand side is Zoom. Zoom does background replacement. So it understands who you are and then cuts the background so it won't be all of the things that I have there on the sofa, and just put something else that I've decided as a background. Skype does something similar but different. They blur the background. So you see the background without the image in the center. You see the background, but not exactly. Okay? A company that is not here, Cisco, for example, identifies people, and then it will put name tags under each person within the same video. So think room system or a meeting room. You have 4 people around the room, and you will have names under each one of them. So you know who's each one and who's speaking. Now on the right, we've got Facebook lenses. So there is a person, and we're going to put a silly hat or something else around him, just by understanding where he is situated in front of the camera. Okay, so that's a way of using computer vision in real time to do different things to manipulate the images themselves. I can use the same things just to do what Chad said before, like counting the number of people in the room, which is important to understand the utilization of meeting rooms, or to be able to do auto zoom. In a large room, I will zoom directly to the person speaking and move on to others as the speaker changes within the room or as people move inside the room. Now, an example about real-time communications optimization is something that we've seen at the last Cranky Geek show, where House Party came and Gustavo Garcia, this is him by the way, showed what they are experimenting with, which is to say you have a large-scale system and that system is sending video. And sometimes the network is good, sometimes the network is bad. When the network is bad, the resolutions or the bit rates that you can send over the network starts going down and the quality will go down as well. So what we see here on the left side is the original frame that was sent over the network, okay, or the one that we had taken from the camera, sorry. The one in the middle is the one that got encoded and sent over to the other side. Now the other side could have decoded it and got the same image like the one in the center. But what they did later was apply machine learning on that image in real time. Okay, I think it was 30 frames per second in this case, which is quite good. And it improved the images. It recovered some of the original parts and components that were in the image. And this is where we're headed. We have a lot of algorithms today that go into communications. Jitter buffering, echo cancellation, encoding, decoding, how you send over the network. All of these are done today using rules. Developers came, decided how to compress, how to encode, how to decode, and then they used the rule engine to decide what to do next. And they added more and more rules to be able to compensate for different issues that happened on the network. And now we start seeing companies looking at machine learning in order to do the next step or the next leap on how to improve quality in these exact areas by replacing the algorithms that they have with ones that are based on machine learning.
So now I'll tell you a little bit more about the report. First, I think our original goal, Sai, was to have the report be something like 50 pages. We ended up at 147. We provide a lot of good detail and analysis. So the report starts out with a machine learning overview, and then we dive into some specific sections based on the 4 areas that we reviewed earlier, right? And for each of those, we discuss use cases. We look at the technology stacks. We dig into some of the drivers and inhibitors within those areas, and look at the various different vendors and the vendor landscape. And we spent a lot of time. Our goal here is really to help companies implement and deploy this technology. So we spent a lot of time going through various different product selection criteria, helping to really list what are some of the key areas and things you should ask about our capabilities you should be aware of, right? And then we finish up with some recommendations and include the full results from our industry survey. It has lots of figures and tables and graphs and a lot of references there. So it's ended up being a very comprehensive report. Took a lot longer, I think, than planned to complete, but was definitely a very good experience for us.
It was also fun.
Yes.
To some extent, at least. I learned a lot through the process. So anyways, what I wanted to ask you is what are you going to do with AI in RTC and how are you going to bring that into your companies? To help you out, the discount is actually larger. We had a different slide here that was supposed to be here. We'll switch that at least in the recording. But essentially what we're offering is a $2,000 discount, which brings the price of this report to $950. And in order to use that discount, you just need to go to crankygeek.com/research and use the coupon code ARWebinar. And the discount will be applied immediately. If you'd like to ask questions, just you can do it now. You can do it later over email. We're also available for consulting, by the way. So I'd like to open up now the room for any questions that you might have. You can put there either in the Q&A tab or here within the chat itself. I have one for you, Chad, until we get people started.
Okay.
When you go today to companies that ask you where to start, Okay, we have a communication solution. We probably support speech to text somewhere because we've licensed, whatever Nuance said 5 or 10 years ago, and we're using that in a very small part of our service. What should we do next? How would you go about helping such a vendor?
Well, I do think it depends, certainly on a lot of things. In most cases, the public cloud vendor APIs and some of those, available from the specialist vendors, it's better than the open source stuff, and certainly much easier to work with. So if the vendor has a team that's capable of it, if they have the resources available to and are willing to invest, and in some cases it makes they don't have much choice, right? If you're competing against Google, or if you're competing against Google, Microsoft, and Amazon, then you probably don't want to go out and use their APIs, right? So that's going to put you in a different path, like working with some of the specialist vendors or working with open source. If you have a very low cost product, then maybe you don't have any choice but to use the open source and do something simple. So I guess I would start by digging into a little bit more of their situation and what they're looking to accomplish out there. But the good news is, like, if you can think of it, it's probably possible. A lot of this stuff is being done already in production. In some cases it might be a smaller scale, but there's so much that's really exciting things that are being done. And a lot of these capabilities just aren't restricted to big companies like Google and IBM. Like you can go out and do this on your own if you want.
One of the things that I've seen is that this question, between using a cloud API to going DIY and build it on your own, is awfully relevant to those that have access to data scientists with domain knowledge in the domain that you're trying to reach out to. So I remember one of the large vendors that we've talked to said that the way they dealt with it, because they are in the Bay Area and they wanted to, have machine learning added into their products. And they said, we're going to DIY this, but there's a problem. We can't even hire data scientists in the Bay Area, because these either go to startups or they get sucked out of the atmosphere by Google and Facebook and Amazon, and that's it. There's no way to hire them for mid-sized or large-sized company that wants to do machine learning. And what they ended up doing, if you remember, was to go and open up Coursera courses around machine learning to all of the developers in the company, with the intent and the idea that at least 10% of the people would actually start learning and using machine learning internally. So instead of hiring external developers, when they went to the DIY route, they decided to train their employees towards that goal.
Yeah, I definitely see universally, engineers want to learn this stuff. It's like, imagine not learning the web or not learning mobile. It's the same caliber, or maybe more, right? So it is extremely important for developers to get to learn this stuff and get used to it. I do find the learning curve is very steep. It can be very steep. The good news though is it's like it's so much easier to get started now than it was just a year or two ago. And they keep improving the APIs, right? So even TensorFlow's, on the second version, much easier to use now than it used to be. So it's getting better. And as the industry matures, it'll be easier to learn, and then I'll pull more people in, and I think that'll help to accelerate, make it easier and more accessible. But we're still in the relatively early stages, but there's really a great time to get involved. It's not to the point where it's so easy it's not valuable anymore. I think we're a long way away from that. But if you're willing to make somewhat of a commitment and effort to it, there's a lot of room for payout here.
Okay, there's a question here that I don't have the answer to. I'll read it out and I'll see. Let's see if you can help me out, Chad. So Matthew is asking, are you familiar with Dragon Naturally Speaking, locally installed software that essentially allows individual users to manipulate the speech recognition algorithms so that different text comes up than what is spoken by design? Can any of the big cloud ASR engines do this in their APIs?
Yes. So yeah, we don't talk. I mean, there are. I'll say in general. I mean, Nuance owns Dragon, right? And they've been doing this stuff for a long time. I have most of the cloud vendors provide something that's comparable, or in some cases maybe better, or a lot of cases better. All the major speech to text vendors have what's known as custom dictionaries, right, where you can define your vocabulary. So, like in this case, we're using AI and RTC, right? RTC is not a word that shows up in the usual dictionary. When you send the speech to the API, you can send it, hey, one of our words that we use a lot is RTC, and it has that dictionary. And if it finds something that looks or sounds like RTC, it'll change that to RTC. That's absolutely something that's there. Mm-hmm. In addition, most of the cloud vendors now have some means of customizing even the acoustic environment. So IBM has this, Google has this, Microsoft has it, Amazon has it now too, where you can specify, is this a telephony environment? Because especially in traditional like PSTN audio, where you have like G711 and narrowband, like the acoustic properties are a lot worse than they are when you have wideband, and sounds good. So they're tuned for those environments. So you can also specify that, and that helps to improve the conversion accuracy.
Matthew, did that answer a question? You can put it in the chat. Okay. It brings me to one more thing within the question, which was locally installed. This is something we also debated and discussed during the creation of the report. The fact of where you do the training, which means where you collect all of the data and build the actual model, versus where you run the inference, which means taking the model and running it in real time on new data. And some of these speech-to-text things you do in APIs in the cloud today, but we're starting to see them happening on phones directly as well.
Yeah, I was thinking maybe we needed a slide on like Core ML and something like the Android and iOS, because this stuff, the technology is not just available in the cloud. Actually, it's available on your mobile device with APIs that take advantage of that. And the chips, like I showed that AI Vision chip, with an Intel Movidius chip, but those chips, I mean, that a similar version of that chip is available on like Google Pixel phones, for example, right? So some of the hardware is there and available, and you don't necessarily have to do stuff in the cloud. Another interesting trend too, like if you're deciding like, is it right to do it in the cloud or on the edge? I guess the edge is called edge ML, edge machine learning. If as an example, Google basically doesn't necessarily say there's a right approach, right? So Google has their cloud-based TPU, their tensor processor units, which are super efficient machine learning processors, right? And now they have an edge TPU, right, that actually you can buy and works inside an embedded device, right? So if you want it in the cloud at scale, you can do that. If you need it in a power-friendly, small scale form factor local device, so you don't have to talk to the cloud at all or all the time, that's also an option too.
Mm-hmm. Yes, it's like machine learning everywhere.
And that's certainly that's kind of I think that's the trend, right? Just like software's everywhere software goes, machine learning is probably going to follow it.
Any additional questions to us? Okay. Seeing none, I'd like to thank you all for being here with us, and see us in the next webinars that we're going to have. Bye for now.
Yeah. Thanks. See you all.